we're going to be looking at modeling linear relationships. One of the most common questions I get asked is, where will I use this in real life? With modeling linear relationships, off the top of my head, the first thing I can think of is hiring a car. So for example, if you're trying to compare the price of hiring a car through Thrifty and Avis, you could plot a linear relationship and see which one offers you the best value for dollar. So linear relationships help us to identify the relationship between two variables. For example, if we look at the area of a square, we can see that it can be represented by the equation A equals length times length. So what this tells us is that we're looking at the relationship between the area versus the length of each side of the square. If one of the variables changes at a constant rate compared to the other, we say that there is a linear relationship. So let's look at a pretty straightforward example, but it is a worked example of a linear relationship. So in this situation, JB Hi-Fi sells DVDs for $9 each and then charges a flat rate of $7 for the delivery of any number of DVDs ordered. So here, I did say that was each, even though I didn't write it. And we have a flat rate. So this suggests that this is a constant. Now, this is a real life example, even though the prices of the DVDs are obviously not correct. A flat rate means that regardless of how many DVDs JB sells to a particular consumer, they're going to be paying a flat rate of $7. So for example, if I were to purchase 3 DVDs, I'd be paying $9 per DVD ordered, but I'd only pay a flat rate of $7. I could also then go and purchase 20 DVDs and I'd still be paying that $7 for delivery. So this becomes quite important when we're setting up our linear equation. So step 1 says to find a rule connecting the cost. So we're looking at using the C as our variable with the number of DVDs delivered. Let's let that be D. So if we set up a rule, we're going to say that cost is equal to 9D, because remember each DVD costs the consumer $9 each. So if I were to order 3 DVDs, I'd do 9 times 3. If D was 10, I'd do 9 times 10. And a flat rate of $7. So that $7 does not change whether I order 1 DVD or whether I order 100. So this is the rule connecting the cost. Now, notice that I've used the variables that we've been asked to use. Please do not use X or Y if the particular question does not ask for X or Y. In this case, the particular question didn't actually specify what DVDs ordered should be, so I've let it equal D. Part 2 says to use the rule to find out how much it costs for 20 DVDs to be purchased. So in this situation, D is equal to 20, and what I'm trying to solve for is cost. So substituting that in, I'm going to do 9 times 20 plus 7 equals my cost, and therefore my cost is going to be 180 plus 7, so my cost is 187. Now, because the question is asked to me in words, I'm going to write my response in words. So to purchase 20 DVDs cost $187. Then part 3 asks us how many DVDs can be delivered for $97. So again, looking back at the rule that we wrote for part 1, we said that the cost is equal to 9 times the number of DVDs ordered plus 7. So what we're trying to find this time is, what does D equal when C is equal to $97? Substituting that into the equation, I'm going to do 97 equals 9D plus 7. Now remember, I'm solving for D, which means I need to rearrange the equation. The first thing I'm going to do is take this 7 to the other side, so to the left-hand side, becoming 97 minus 7 equals 9D. That'll give me an answer of 90 equals 9D. I want D by itself, so I'm going to divide by 9 on both sides, pardon me while my pen stops working, they will cancel out, and that'll leave me with 10. So simplify where possible, because you never know if you're going to get a whole number, and if you're not sure, please use a calculator. And we just found that D equals 10, which means, again putting my answer back in words, that 10 DVDs can be delivered for $97. So this is just a basic example to get us into thinking about linear relationships in a real life situation and in a worded scenario. As we move through the unit, we'll get into a few more complicated ones. For example, graphing a linear relationship of how much it costs to hire a car, or even a break-even analysis for a small business.